Hi everyone, I am Santi from Department of Mathematics and Statistics, Bhavan Vivekananda College. I am here with my lesson 22 from Linear Algebra on vector spaces. In this lesson, I am going to discuss some more points on rank of a matrix. It is like what will be rank of a matrix, transpose of a matrix, and what will be maximum possible rank for matrix, what will be minimum possible dimension for null A, maximum possible dimension for column A. All these points relating to rank of a matrix we will be discussing in this lesson. Now, after working out a problem on rank of A and dimension column A, dimension row A and dimension null A, let us look at some more points which we can remember about a matrix A and its transpose and the rank of the matrix A and rank of transpose, all the equations. The first point is rank of A is equal to rank of A transpose. That means if you transpose a matrix, its rank will not change. Then the second point, rank of A is equal to dimension column A by definition. But dimension column A is equal to dimension of row A transpose. This we have learned in the previous lesson. But dimension of row A transpose is equal to dimension of row A. And again dimension row A is equal to dimension of column A transpose. So we can say in general that all these dimension column A, dimension column A transpose, dimension row A transpose. All these four are equal and they are equal to even rank of the matrix A. Now the third point. So in this third point, we will analyze some case 1, case 2 points, two criteria conditions whether we have, when we have different rectangular matrices. Suppose for a matrix A m by n, what will be maximum possible rank? It has m rows and n columns. What will be maximum possible rank? So here first I will state that the maximum possible rank for A is equal to minimum of m comma n. That is minimum of number of rows comma number of columns. Let us go through it elaborately. I will take case 1. Consider a matrix A of order 5 by 8. That means it has 5 rows and 8 columns. Now, for each pivot column, so there are 8 columns, then for each pivot column, there must exist a row with a pivot position. This we learnt earlier. If there is a pivot column, there should be a row also with a pivot position. That means there should be how many pivot columns are there, those many non-zero rows should be there. That implies for each pivot column there exists even a pivot row, I can say. Now I have 8 columns, then can I have 8 rows also? But here how many rows we have? Only 5 rows for the matrix. When you have only 5 rows, how can you have 8 rows with pivot position? So here you can see you have here only 5 rows. When you have only 5 rows, how can you have 8 rows with pivot position? So maximum how many rows I can have with pivot positions? Only 5. So here I can say though A has 8 columns, it cannot have either 8 or 7 or 6 pivot columns because A has only 5 rows. Because if all 8 are pivot columns, there should be 8 pivot rows, which is not possible. Then can there be 7 pivot columns? No, because if there are 7 pivot columns, there should be 7 rows correspondingly. No. Can there be 6 pivot columns? No, because if 6 pivot columns are there, again 6 rows must be there. So what is the possibility? It has only 5 rows. So we can conclude here that A can have maximum 5 columns as pivot columns. Though it has 8 columns here, it can have maximum only 5 columns, maximum 5 columns. It can have 4, 3, 2, 1, but it cannot have more than 5. That is the point. A can have maximum 5 columns as pivot columns. Now let us look at the second case. I'll take now the matrix of order 8 by 5. I interchanged columns and rows. Now, again I'll argue the same. For each pivot column, there must exist a row with a pivot position. Now I have for each pivot column, there exists a pivot row, the same argument as before. Now I have 8 rows, then can I have all 8 rows with pivot positions? No, because I have only 5 columns. If all 8 rows should be with pivot positions, I should have even 8 columns, but I don't have. I have only 5 columns here. I have only 5 columns. So, though A has 8 rows, it cannot have 8 or 7 or 6 pivot columns because A has only 5 rows, 5 columns. That implies A can have maximum 5 columns as pivot columns. Now let us observe here. This is a matrix with 5 by 8. What is maximum pivot columns? 5. This is a matrix with 8 by 5. What is maximum columns, maximum number of columns for as pivot columns? 5. So what can you say here? Among these 5, 8 and 8, 5, whichever is the minimum. What is the minimum number? 5. That 5 will be the maximum number of pivot columns, not more than that. So number of pivot columns is nothing but it is equal to the rank of the matrix A. Therefore, maximum possible rank for A is equal to minimum of 5, 8, or that is equal to minimum of 8, 5. Whether you say minimum 5, 8 or minimum 8, 5, it is the same, which is equal to 5. So that is what in general I can say maximum possible rank for A is equal to minimum of m, n. Now let us look at the next point. I gave you the maximum possibility for rank. What will be minimum dimension for row space A or column A, or you can say minimum possibility for rank also. So the minimum dimension for row A or column A is equal to 1. Because it can less than 1, it cannot. If it has number of like dimension column A, if it is dimension column A is less than 1, that is 0. What does it mean? It means matrix has no pivot columns. If a matrix has no pivot columns, then it will have all 0 entries. That matrix will be a 0 matrix. So a matrix, every matrix should have minimum one pivot column. A matrix should have. That's why dimension of row A, minimum one non-zero row should be there. If all are 0 rows, then we don't calculate anything for that. It's a 0 matrix. So there should be minimum one non-zero row, minimum one pivot column. That means we can say here that the minimum dimension for row space of row A or column A must be 1. Since there will be minimum one pivot column in an echelon form of a non-zero matrix. Hence, what can we say? Minimum rank for any matrix is minimum dimension column A, that is 1. In the previous we gave what is the maximum rank? Maximum rank is minimum of the number of columns, number of rows, whichever is minimum. Then minimum rank dimension for the rank is equal to minimum dimension for column A, that is equal to 1. The rank is minimum value is 1. It cannot be less than 1. It cannot be 0. It can be more than that also. Now let us look at the next point. By rank theorem, we have rank A plus dimension A is equal to n, that is number of columns. That implies dimension of null A is equal to n minus rank of A. That implies minimum dimension for null A is equal to n minus maximum possible rank for A. That is equal to n minus minimum of m, n. So this is a minimum dimension for null space. What is that? N minus minimum of m, minimum of number of rows, number of columns. For example, suppose I have n is equal to 5 number of columns and m is equal to 10. Then what is minimum dimension for null A is equal to n is 5 minus minimum of 10 comma 5, that is equal to 5 minus 5, which is equal to 0. So minimum dimension null A can be 0 also. Suppose I change this. N is equal to 5 and m is equal to 3. Then what is minimum dimension for null A then? Minimum dimension for null A is equal to total number of columns 5 minus minimum of m comma n, that is 3 comma 5 is equal to 5 minus minimum of 3 comma 5 is 3, which is 2. So according to this formula you can find out what will be the minimum dimension for the null space. So we have seen maximum rank, maximum dimension for column A. We have seen minimum dimension for column A. Now we have seen even minimum dimension for null A. And the next point, we can say here by rank theorem we have rank A plus dimension of null A is equal to n, which implies dimension null A is equal to n minus rank A, the same thing. So here I gave what is the minimum dimension for null A, what is the maximum dimension for null A. Minimum dimension for null A is equal to n minus maximum possible rank for A, that is n minus minimum of m comma n. And what is maximum dimension for null A? N minus minimum possible for rank A. What is minimum possible for rank A? 1. N minus 1. So a matrix can have maximum dimension of null A. Maximum it can be n minus 1. That is, if n is equal to 5, then a matrix null A dimension should be is equal to minimum dimension. Not minimum, sorry, maximum dimension for null A is equal to 5 minus 1 is equal to 4. It cannot have 5 if there are n 5 number of columns. It cannot have dimension null A is equal to 5. Maximum it is 4. It can be 4, 3, 2, 1, 0. It cannot be 5 or more than 5. Now let us look at this example. It is given here, if a 4 by 7 matrix A has rank 3, then find dimension null A, dimension row A, and rank of A transpose. Let us look at the solution. Your matrix A is given with the order 4 by 7. So I have m rows, 4 rows, and m is equal to 7. And we are also given that rank of A is equal to 3. So first one, dimension null A, dimension row A, rank A transpose. So if rank of A is equal to 3 and the number of rows is 7, what do we have? Rank theorem. Rank theorem states that rank of A plus dimension null A is equal to number of columns. So rank of A is 3 and you don't know dimension null A. This you have to find is equal to 7, implies dimension null A is equal to 7 minus 3, which is 4. So dimension null A we found, and then next one we have to find dimension row A. Then dimension row A is equal to, even it is equal to rank of A. So that is equal to 3, and the second one is done. So first one we have done, and the second one is done, and the third one is rank of A transpose is nothing but rank of A. So that is also equal to 3. The third one is also done. Now let us look at the another example. So second example, If the null space, if the null space, null can I say of a matrix A of order 8 by 5 is three-dimensional, then what is the dimension of a row space of A? So let us look at the solution. What is given to us here? Matrix A with 8 by 5 order. So M is equal to 8, N is equal to 5, and it is given if the null A of matrix A is of order 3. That is, dimension of null A is equal to 3. Then what is the dimension of row space? So we know that dimension, we have dimension row space A is equal to, it's nothing but a rank of A only. And then by rank theorem, we have rank of A plus dimension of null A is equal to number of columns. So rank of A only we have to find, implies rank of A plus what is dimension A, this is equal to 5, implies rank of A is equal to 2. Therefore dimension of row A is also equal to 2. That is the next question. Now let us look at the other question. Question number 3. A is a 6 by 8 matrix. A is a 6 by 8 matrix with 4 pivot columns. Then what is dimension null A? And another question is in the same one, is column A subspace of R4? Now let us look at the solution. A is a 6 by 8 matrix. So A is 6 by 8, M is equal to 6 and N is equal to 8 with 4 pivot columns. So you are given number of pivot columns is equal to 4, implies I can immediately say dimension column A is equal to, and rank A is also equal to 4, because we know number of pivot columns and dimension column A, dimension and the rank all are the same. So rank is, what do we have to find now? What is dimension of null A? So again we will use rank theorem statement. Rank theorem, what do we have? Rank of A plus dimensional A is equal to n, and then 4 plus dimensional A is equal to n is equal to 8, implies dimensional A is equal to 4. And what else is given? What is dimensional A? So is column A subset of R4? So what is dimension here? Column A. Let us see. Dimension column A is equal to it is 4, but we have dimension of not dimension, we have for any matrix A m by n, column A is a subset of Rm, because why? Because since each column has m rows, That is the reason. So here what is m here for us? For us m is equal to number of rows. M is equal to 6. So here m is equal to 6 implies column A is a subset of R6, but column A cannot be a subset of R4. Though here you can see rank of A is equal to dimension of column A is 4. Here we got it as dimension of column A is equal to 4. It doesn't mean that column A is a subset of R4. So here you can say, note, you can remember dimension column A is equal to 4 does not mean that column A is a subset of R4. This you have to remember as a point after this problem. Now let us look at the another problem. So this is question number, I think, 4. So it is given, suppose A is a 4 by 7 matrix. A is a 4 by 7 matrix and A has 4 pivot columns. Then what is it asked here? Is column A equal to R4? Second one, is null A equal to R3? Explain. So let us look at the solution. So here A is given a 4 by 7 matrix and here M is equal to 4 and N is equal to 7. Then what do we have? And also given here number of pivot columns. Number of pivot columns is equal to 4. It implies dimension of column A is also equal to 4. Right. That implies, what do you mean by dimension of column A is equal to 4? Column A is span of, or I can say column A has a basis with 4 vectors. Let us a basis with 4 vectors where each vector has how many rows? It will have m is equal to 4 rows. That implies, and we all know, also we have column A is a subspace of R4. Now, cannot say column A is nothing but R4. Column A is a subspace of R4, but you cannot say that column A covers. What does column A has? It has all the possible linear combinations of, let us suppose, let column A is equal to span of, let me say V1, V2, V3, V4. Then 4 vectors, then this one let us take in where I can say also this V1, V2, V3, V4 is a basis for R4 also. That implies I can even say implies we can have span of V1, V2, V3, V4 is also equal to R4. So if I say this is equation 1 and this is equation 2, what do we have? Column A is span of these 4 vectors. Also V1, V2, V3, V4 is a basis for R4 by because these are 4-dimensional vectors. Each vector has 4 rows. Therefore, we can have span of V1, V2, V3, V4. These form basis for R4 also. Right. That is implies from 1 and 2 we can say column A is nothing but R4. So this first condition what is asked here, it is true. And let us look at the second condition. What is that? So what is that when about null A? So we know that we have null A must be a subspace of, according to a known theorem, is a subspace of Rn where n is the number of columns. So here, therefore here null A must be is a subspace of, what is n value number of columns here? R7. Subspace of R7 and there, which implies null A is not equal to R3. That is what the second question. Now let us go for the next question. If A is a 5 by 4 matrix, A is a 5 by 4 matrix, what is the largest possible dimension? What is the largest possible dimension of the row space of A? That is the first question. And the second question in this only continuation, if A is of 4 by 5 matrix, if A is a 4 by 5 matrix, then what is the largest possible dimension of the row space? So here let us look at the solution. Let me take the first case. A is of order 5 by 4. So I have m is equal to 5, n is equal to 4. Then we have to find out what is the largest possible dimension row space. Largest possible dimension row space is nothing but largest possible rank. Possible rank for A. That we already learnt it. What is the largest possible rank is equal to minimum of m comma n, that is equal to minimum of 5 comma 4, which is equal to 4. Now the same way if we look at the second bit in this, A is now 4 by 5. So here m is equal to 4, n is equal to 5, but and here also the same logic if we apply, therefore largest possible dimension row space, here also it is equal to the same minimum of 5 comma 4, which is also equal to 4. So in both the cases it is 4 only. Now let us look at the next problem. If A is a 3 by 7 matrix, if A is a 3 by 7 matrix, what is the smallest possibility? What is the smallest possible dimension of null A? And smallest possible dimension of row space also, row space of A. So A is a 3 by 7 matrix. Let us, A is 3 by 7, and then n is equal to 3, n is equal to 7. And then what is the minimum dimension for null space? What do we have? Dimension null A is equal to n minus rank of A, which implies minimum dimension, or I can say smallest possible dimension, smallest possible dimension null A is equal to n minus largest possible rank. So this is equal to n minus minimum of m comma n. So n is equal to 7 minus minimum of 3 comma 7. So this is equal to 7 minus 3. This is equal to 4. So smallest possible dimension is 4. Now let us see, look for the second bit in this. What is it asked here? Null A and smallest possible dimension of row space. So the smallest possible dimension for row space, actually for any matrix, smallest possible dimension for row space for any matrix is always equal to 1. What is the reason? Since there should be minimum one non-zero row, or you can say minimum one pivot column. So irrespective of whatever the order of the matrix, the smallest possible dimension in row space for any matrix is 1. That is it. Next question. So with this question, I think we have finished the problems on this.